So, using the Understanding Society study for longitudinal research. So what is the Understanding Society? The Understanding Society is a survey, and the official name is the UK Household Longitudinal Study, and it's conducted by the University of Essex since 2009. So it's been around for more than 10 years now. And in Essex, they have a whole research institute, the Institute for Social and Economic Research, that has been working and developing this study, and it's really a huge study, right? So obviously, I wouldn't be able to tell you everything about the Understanding Society today, and that's not my intention at all. And even to cover 5% of what they have in the data would require serious workshops. So it's a very big study, very well developed with a very complex structure. So we are going to focus on one particular thing. And this thing is going to be the data structures in the Understanding Society. And let me explain what I mean by this. So the official name of the survey, the UK Household Longitudinal Study. And there are two words here that are important: longitudinal and household. Longitudinal means that the study has a time component. So these are individuals surveyed repeatedly over time in multiple waves. So the same individuals get asked questions multiple times. So far, I think the data for 10 waves have been released. So we have multiple data points for the same individuals. What is household? Household means that the households, rather than individuals, are the sampling units. And the units of observations as well in the data. So for most surveys, what you have is the individual level data. And the way it works for many surveys is that, okay, sampling may be done at the household level, but then what survey organizers do is they select randomly or following a particular procedure a person within a household, and each household is represented by one person, which is not the case in the Understanding Society. In the Understanding Society, sampling is done at the household level, and also the organizers of the survey and the people who do field work, they try to interview everyone in the household, right? You can see the link to the Service Understanding Society's website, where you can find more information about the structure of the survey and other things. But the survey being longitudinal and household at the same time adds two levels of complexity to the data structures, right? Longitudinal means that there are multiple data files for different waves. Household means that we have observations both at the individual level and at the household level at the same time. And these two things make working with the Understanding Society quite difficult for people who haven't done much quantitative work before, and to be honest, even for people who have done quantitative work before, but maybe with data with simpler structure. And it's easy to kind of get lost in the data before you even get started. So my intention today is to clarify this and to help you, if any of you is intending to work with Understanding Society data, to help you navigate the data files really, and to establish links between different data files. Okay, right. So what are the data about? Again, that's not my intention to cover everything they have in the data files, and that's a lot of information. You can follow the link. Obviously, I'll make the slides available, and you can find the information about the study content, but that's a lot of topics about demographics, about households, about labor market position of individuals within households, the education, attitudes and values, political attitudes, health data, and there are lots of other things that are not part of the main release of the data. For example, at some point, the study organizers collected saliva samples from study participants, so you can have access to genetic information. There is a separate innovation panel that they try, where they try different methodological innovation related to this study design and modes of data collection. There's a separate longitudinal COVID-19 survey on a separate sample and it's a separate data release. There are data sets that link the Understanding Society data with the National Pupil Database, which is a database collected by the Department for Education that contains information about all pupils in state schools in England, and that's data from school censuses. So you can have this. There is a linkage between the Understanding Society data and the DVLA data. Lots of things, right? And again, not to get lost in all of these things, what we are going to do is to focus on a very particular thing, data structures. The Institute for Social and Economic Research provide their own training for the Understanding of Society data, and they know the data much better than I, right? Because that's their main job, to work with this data and develop this data. So you can follow this link to see what training and what webinars are available. Many webinars are available in public access. You can also sign up for that training at the University of Essex. So that's all available. But I think there is a gap in what they currently offer as training, and the gap is exactly about data structures. They offer lots of things, including the introduction to the data, but what we're going to focus on today is how to establish links between different data files and what kind of questions you can ask where you can join different data from different data files together. My own experience with Understanding Society comes mostly from using it for teaching, really. So I've been teaching a module called Data Analysis 3 at the University of Exeter. That's an advanced undergraduate module, and that's a kind of data science sort of thing in R. So I was looking for a data set that would have some social relevance and would have a very complex structure, because that's what I wanted for my module, to explain to students how relational databases work and what you can do with complex structures, with data with complex structure. So I've been using the Understanding Society for teaching for about 5 years now, and that's where my own experience with the data set comes from. Okay, right. So as I said, the data structure is quite complex, and the complexity comes from having several levels of data. So you've got households, some data collected at the household level. You can easily think of household variables. For example, what kind of, this would be the type of accommodation, right? Whether it's owned or rented, and household incomes, and other variables. But most variables are measured at the individual level. So you have the nested structure, you have individuals nested within households. You also have data collected in multiple waves, and this data relates to the same individuals. So for each individual, you would have data from several waves of the data for most individuals. So you have individuals nested within years or waves. Then you have time constant and time variable characteristics of individuals. You can think of time constant characteristic of individuals such as, for example, birth year. The birth year doesn't change over time, right? Your age changes over time, obviously, but the birth year doesn't change over time. What else doesn't change over time? The characteristics of your parents, for example, where they were born, don't change over time. Your place of birth is not going to change over time. It just happens, right? So many characteristics are time constant. And with time constant characteristics, it doesn't make sense to ask about them in every wave of data collection, right? Imagine you participate in a survey like this and you get asked questions every year, and there's been 10 waves. Imagine they ask about your ethnicity every time. You'll get tired very quickly of this, right? So some questions just get asked once, and these are related to time constant characteristics of individuals. But for some characteristics, these are time variable characteristics. For example, your income that changes every year, potentially. So these are recorded separately. And all this makes it, make the Understanding Society a data set that is difficult for researchers to use. So let's see what we can do with this data set. So today, and that's my last slide, and then I'll move to RStudio. What I'm going to do today, to show you today, is how to perform the most common data management task with the Understanding Society using R and the tidyverse framework in R. So the tidyverse is a collection of packages in R that help you with really with data management tasks. So it's kind of data science in R is often performed using tidyverse, right? And particularly, we are going to look at the following tasks. We are going to look at how to link data on individuals over time. So how to link data for the same individuals from multiple waves in the Understanding Society. We are going to look at how to link the data on individuals and households. We are going to look at how to identify relationships between individuals within the same household, right? And we'll look at how to present and analyze data in different formats, specifically in the long and the wide formats. And don't worry if you don't know what these are, right? Some syntax files are already available for these tasks, are already available at the Understanding Society website. These are mostly for Stata. They've got something in R as well, but mostly, I think mostly people who work with the data in Essex, they've been using Stata. So some syntax files are available there, but not everything, right? So hopefully, if you work with the Understanding Society data, or if that's your intention, hopefully what I'm going to show you will help you with getting started with data management and data structures. Right, so I'll close the presentation now, which I'll make available later, and I'll go to RStudio. Now, can you read everything on the screen? Is the font size big enough for you? Yeah, great. So let's get started. First thing I'm doing, I'm attaching the package tidyverse. It's really a collection of packages. These are the packages that have been attached. And then there is one more package that I want to attach, is called Vroom. That's the package to read data into R. There are many packages that help you import data into R, but that's one of them, and it works. It's quite fast. That's why I'm going to use it today, right? You do need to install those packages before you attach them. I've installed them already, but if you are going to use the script, you need to install the packages first. So what I'm going to do, I have 5 examples here of the most common data tasks, or not so common, but interesting. And I'll show you things I wanted to show you using those examples, right? So example 1. So, for example, let's imagine we want to see how many individuals who took part in wave 1, which happened in 2009, 2011, were still in the sample in wave 10, that's 2018, 2020, right? In longitudinal service, you always have sample attrition. So first, what you do in the first wave, you construct a representative sample, but obviously in the next wave, not every member of your sample is going to participate in your survey again. And over time, the sample is going to become smaller and smaller and smaller. That's called sample attrition. That's inevitable. Ideally, you want the sample attrition not to be too large, because otherwise, not too strong, otherwise the sample loses representativeness. So let's see how we can do this. And this obviously, kind of technically, that requires linking data records on individuals from wave 1 and data records from individuals from wave 10, right? So let's start from reading in the data for wave 1. And before I tell you about this, I need to show you where to access the data. And the data are available for download at the UK Data Service website. So if you go to the UK Data Service website, here you can find the data. There's a data catalog. You can find the Understanding Society, register. Usually you can use your university credentials to register, to log in and download the data. For the Understanding Society, there are separate releases. We use the main release that you can download without any additional requirements, such as getting some additional training and so on. And there are 3 data formats you can get access to on the UK Data Service website for the Understanding Society. That's going to be SPSS data and tab separated values. For R, because I work in R, I always use the tab separated values, and that's what I have. That's the folder here, UKDA 6614 tab. That's the folder where I have all the data files that I've downloaded from the UK Data Service website, right? And that's my data structure. So the tab, this folder tab contains all the data files, and you see the multiple folders here just to show you the complexity of the data. So these folders relate to the British Household Panel Survey. That was a household panel survey, a longitudinal survey that predated the Understanding Society. But for the Understanding Society, you have 10 waves here. Then we have a folder with the cross-wave information. And if I open the folder for wave 1, for example, you see it's not just one data file. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data files for wave 1, and there are 10 waves. So approximately we've got, it's not 15 for every wave, but we've got over 100 data files. And that's confusing, right? For many people who work with quantitative data, what we used to do, Stata users, there's one data file, you open it in Stata and you work with this data file, right? That's what you do. No, I mean, maybe you do something different, but that's what I used to do when I worked with most services. And are the same, right? It doesn't matter which software you use, but kind of our psychologically, people who do quantitative research often in social science always get used to this kind of idea of using one data files. Here we have many different data files, and it's easy to get confused, right? Okay, so what we need here, we need to, there's a question in the chat. Okay, I'll do it later. What we need to do is to read the data from wave 1, and the data from wave 1 are here. For wave one data files all have the prefix A, right? So when you have a data file started with A, that's from wave 1, right? So what I'm going to use the Vroom package to open the data. The reason why I'm using Vroom is that it's very fast, right? This speed comes with, there's always a price you're paying, but that's not very important for today. So, and then you can see here I've got the data file. That's my data here, right? Now we need the data for wave 10, and these are data from INDRESP files. So these are in records for individuals. So these are data from wave 10. Okay. So now if you look at wave 1 and wave 10 data, what you need to do now in order to be able to say how many people from wave 1 are still there in wave 10, you need to link these two data sets together. And that's a common task for relational databases, right? So that's essentially, that's what people who do this kind of work do all the time. And to join these two data sets together, you need a unique identifier for each individual, which we do have in the Understanding Society, and it's called PIDP, right? So the first column in the data, that's PIDP, that's a number that uniquely identifies each individual in the survey over time, right? In all data frames we have, which is helpful, right? Because that's how we can join individual records from multiple databases. And the same here, right? So there's PIDP. So what we do here, then, we use a particular function from tidyverse, semi-join. It's a type of join, it's a filtering join. We use the key variable using the language of tidyverse, right? The unique identifier for individuals, PIDP. And we join this data from JINDRESP, that's data from wave 10, with the data from wave 1, A INDRESP, using semi-join. And semi-join is a type of join that is going to return only keep the values in A INDRESP that are also present in J INDRESP. And that's what we want, right? That's exactly because that's our question. So we are actually not going to add any new data to A INDRESP. We are only going to filter this data frame using some information from J INDRESP, right? And then we are going to count the number of the records. So initially, if you look at INDRESP, you've got, it's here, for about 51,000 people in this database, in this data file, right, data frame. Once we filter it with some data from JINDRESP, we get 18,666 people, which shows you the extent of sample attrition, right? So it's still a pretty big number, but the sample attrition, as always in longitudinal study, is quite substantial, right? Summary, the summary from example 1, when you want to link data on individuals over time, use PIDP. That's the unique identifier for individuals. And that's what you can do, link multiple waves together. You can link all 10 waves together. It's going to take you some time. Don't do it manually, write a loop or a function that does it. But basically, the most important lesson for us is to use this unique identifier that identifies all individuals in multiple data files. All right, so another thing that we may want to do, we may want to use, now we just filled, in example 1, we just filtered the data, right? But we may also want to use some data, to add some data from a different wave to another wave, right? For example, we may want to compare the net personal income of individuals in waves 9 and 10. So, okay, we already have the data from wave 10 from these INDRESP files. Now, what we may want to you may want to just trying to change the settings. Sorry. Now, what we may want to do is to open the data from wave 9, right? And that's a different data frame. It has a different prefix, I, right? It's in a different folder. So I've changed the path here. And I don't want everything from this data frame. I only want really 2 variables. That's PIDP, our identifier for individual observations. And that's also the variable for net income, net personal income. Now, how do I know that this is the variable for net personal income? Well, you need to look at the questionnaires. All the questionnaires are also available as part of the data release. Hopefully you can see what I'm doing here. I'm opening the PDF folder and all the questionnaires for multiple waves are here. And the user guide is also there, so you can get this information. But also another thing that I find very useful is the Understanding Society website, where you can have can access information on all the variables. Understanding Society variable search will give you an information on this, for example, variable, enter it without the prefix. Search variables. Here we go. That's total net personal income without no deductions, and you can have more information and distributions from this variable for all 10 waves in the data. Okay. I see that I'm running late, so I was going to present for about 30 minutes. Now it's clear it's going to be a bit longer, but hopefully 10 minutes will be enough for me to finish and go to the rest of the examples, right? So we select these 2 variables, read the data. So now we only have these 2 variables, 2 columns in the data frame, right? So what we want to do now is let's look at the income variable for wave 9. So I use the ggplot package here to create a simple histogram. You can see it here. That's our histogram. Yeah, it's not a very good histogram, clearly, right? Because there are very few people with very, very high incomes. So someone who makes about £90,000 a month, that's a huge income, right? So we want to maybe look only at people with the incomes of below £10,000 per month, which is already quite high. So we can change the limits of our x-axis, and we see a distribution. So that kind of makes sense. You can see that most people have between 1,000 and perhaps 3,000 pounds a month. So it makes sense. Yeah. So now what we want to do, we want to go back to the data from wave 10, that's JINDRESP. And by the way, what I'm doing, I'm using the same names, variable names, as in the original data release. And that's intentional, because when you have so much data, it's very easy to get confused if you start renaming variables, join everything together in one very large data frame. That's not what you do with this kind of data. You want to make it reproducible. You want to keep it clear. So it's a good idea to use the same names as in the original data release. So I take the data from wave 10 here, select two variables from wave 10, the same variables, PIDP and the income variable. Now use full join. That's a different type of join, and what it does, it links the records from wave 10 to wave 9 here, using the PIDP as a unique identifier, and it keeps every single observation in the data frame. So all the observations from wave 9 and all the observations from wave 10. It's always safe to use this type of join, because basically you make sure this way that you don't lose any data. All right, let's see what we get here. So now we have a joint data set, right? So if we have the same information, we have for the same individuals identified by PIDP, we have information on their income in wave 10 here and wave 9 here. What we want to do now is to create a variable with the difference between wave 10 and wave 9. So that's what my next line of code does. Now I have this difference, right? For some people, their income in wave 10 is going to be smaller than in wave 9. For others, it's going to be larger. For some people, if the information on their income in wave 9 is missing for whatever reason, obviously the difference is going to be missing too. And we may want now to summarize this variable. So what I do now, I pull this variable with the difference in the incomes from the data frame and just apply the summary function to it to see the distribution. To see the distribution of this variable, we see that the mean is about 40 pounds. So on average, people had high incomes in wave 10 compared to wave 9, but the difference is not that large. The minimum is minus 100 so basically over 100,000 pounds, right? So the difference is very large, and maybe someone sold their house in wave 9 and that's why their income in wave 10 was so much smaller. So we see a distribution of the variable. Again, that's not my point to examine this difference, but I just wanted to show you how to basically join the data for individuals from multiple waves. So the lesson here, the summary, that you use PIDP as the identifier, but also you want to keep all the observations from the data sets. You use full join to join the data. Okay, let's move to example 3, and I'll answer all the questions in the chat after the finish. Now we want to ask ourselves about whether the difference we just calculated varies by ethnic group, right? So the question is, how does this difference in incomes vary by ethnic group? The problem here, so the problem is just a feature of the data. So the feature of the data here is going to be that ethnicity is a time constant variable in the understanding society. Now, I'm not going to discuss now whether it's a good approach. It feels very primordial, right? If those of you who are familiar with the literature on ethnicity, immediately will be able to identify the weaknesses. So why do we assume that ethnicity is time constant and it cannot change over time? Why do we see it as a stable characteristic of individuals? Obviously, it's possible to have double, multiple ethnic identities and so on, but that's not the point for today, right? So in the understanding society data files, it's treated as a time constant stable variable. And for the time constant variables, respondents usually get asked about it only once, right? And the data on the time constant variables are in a separate file, which is called xwave.dot. Now, what happens if you don't know about this feature of the understanding society data set? What happens is the following. You will be able to find some data on ethnicity in wave 10 as well. So if you use the the file that is specific for wave 10, the file with individual records for wave 10, you will be able to find some data on ethnicity there. However, you will find that it's only there for a small number of individuals and not for everyone. Why is that? Because it's going to be only there for the individuals who join the study for whatever reasons, and there are multiple reasons for this. So the data are going to be there only for those individuals who join the study in wave 10. For the rest of the sample, it's not in wave 10 data. If you don't know it, you keep wondering, so why is ethnicity only there for 3% of your sample? The reason is that you should use, for time constant variables, you should use data from this file, xwave dot, right? So let's read this file, and let's look at the variable names that are there. So there are quite a few here, not so many because there are not so many time constant characteristics. So in the end, at the end, you see these are different types of weights, weight coefficients. These are parental characteristics, but we do have ethnicity. Actually, there are several variables for ethnicity. We are going to use the one that is called trace LDV now. Let's look at the distribution for this variable. So you see the distribution on your screens now. When you use the data in the tab separate format, you're not going to get the labels. If you use the data in this data format, and it's absolutely possible to open the data, the stated data in R, you use the package called Haven for this, you're going to have the labels here. I personally don't like this. I like, to keep it simple. I've got numerical labels, but it's possible to actually check what these labels mean in the data dictionary, right? And that's the approach I take. You don't have to take the same approach, obviously. And there you learn that 1 refers to white British, English, Scottish, Welsh, Northern Irish. 2 is white Irish, 3 Gypsy or Irish traveler, and so on. So you kind of get some idea of what these numbers mean. And it's absolutely, of course, it's possible to recode the variable and convert those numerical labels into proper categorical, proper text labels. Okay, so now what we do is essentially the same thing. We use the PIDP as a unique identifier. It's also here in the time constant data frame. There we go. And we join the data from wave 10 with data with time constant characteristics. So that's something that we've done already, right? That's my code from the previous example. Sorry about this. Right, and then I use left join here because I only want to join to get the data on ethnicity for the people I have in this joint wave 10, wave 9 data frame. So I don't want to have the data for people who participated in wave 1 as well and then dropped out. It's just unnecessary. I could use full join here. I would just get the larger data set with the data frame with a lot of missing values, and I wanted to demonstrate to you different types of joins. So it's safe to use left join here. It's only going to keep the data in the master file. So this one, right? So I join. That's what I get. Lots of information here from the time constant file. Then what I do, I group by ethnicity, and then I summarize and calculate the mean difference in incomes between waves 10 and 9 for my ethnic groups. So if I execute this code, what I'm going to have is for each ethnic group. So 1 is white British. So for the white British, the difference was about £42. For the Irish, it's 53. 9 is Indians, it's 69, about that. Again, of course, there is some sampling variability here, so you should produce confidence intervals as well for those numbers, but that's not the point for today. The point for today is to show you how to link the data from multiple data files. So in the summaries for time constant individual characteristic, you use the data from xwave dot rather than from the wave specific data files. Are we done on time? Not very well. Okay, give me another 5 or 7 minutes for another 2 examples, and then I'll stop. Right, example 4. Another question we may want to ask is about how does the home ownership status vary by age? And that's an example where we have the data from different levels, right? So age is an individual characteristic. The home ownership status, the property ownership status, can be an individual characteristic as well. But for this example, we are going to treat it as a household level characteristic, right? So it's going to be measured at the household levels for a particular house or a flat, right? We are going to record whether it's owned or rented. And these are the data that we have in the household level file. Okay, that's a different level of measurement. So let's read this file first. So this is the household level file, HHRESP from wave 10, as identified by the prefix J, right? So we are going to read this household level file. Let's take a quick look at the file. And you can clearly see here that there is no PIDP. Why is there not? Why don't we have PIDP in the data frame? Because that's measured at the household level. So each row here represents a household rather than an individual. And for the household, we have this identifier. That's another key variable that identifies households in the data. So for wave 10, it's called J_HIDP. Now, the question you may immediately ask is the following. Why for the individuals we have the identifier that is not wave specific, PIDP, it doesn't have any prefixes, right? But for households, we have an identifier that is wave specific. And we know that's wave specific because it has J here, right? Well, the reason is that individuals are units that are stable over time, right? The same individual in wave 1, 2, 3, 4. I mean, you can die and then you stop being part of the understanding society, but an individual cannot, for example, split. Yeah. So it's possible to follow individuals over time. It's not possible to follow households over time because household by definition are changing units. Right? What is a household? Is it the same number, the same people living together? In that case, obviously, people can get divorced or children can move out. So the composition of the household is going to change. If you treat it as an address, again, that's not going to help because people obviously change their address, even if they remain, even if the household composition remains the same. So that's why it's not possible to directly link the same households over time. And that's why we don't have a cross-wave identifier for households, because it's not clear how the household is defined for a particular wave, right? And in the next wave, it's going to be a different household. So now, but that's not a question we need to think about now for this example, because we are only interested here in wave 10 data, so we don't need other waves. So for the wave 10 data here, we need to link the individual level file and the household level file, right? And we need to think about which key variable, which identifier we are going to use. Obviously, that's going to be this one, right? Because there is no PIDP in this data file. But actually, if you look at the individual file, there is a household identifier here, right? Because each individual belongs to a particular household. So let's link these two files. First, I'll start with selecting only 3 variables from my individual data files that are relevant. And that's what you do when you have the data of the same complexity as the understanding society data release, because otherwise, if you don't filter your data, you're going to end up with very, very large files, and it's going to be difficult for you, both for you and your computer computationally, to deal with this. So always kind of try to focus your analysis only on the things you need. So what I have here is the individual identifier, the household identifier, and age, right? Because I only need age here, and the home ownership status will come from the household level data. Now use full join to join this data set with the household level data using the household identifier that is wave specific. All right, there we go. Now lots of other things here, so I immediately want to select only the variables I need. and that's my house on the home ownership status. Again, these are numerical codes that represent particular values of this variable. So 1 is, I think, owned, 2 is owned with a mortgage, and 4 is rented. I'm not going to show you how it looks in the data dictionary because we don't have much time. What I'm doing next, I'm recoding this variable into a binary variable where 1 means that someone owns their home, or rather, because it's a household level, that the home, the house or flat is owned with or without a mortgage, and 0 means that it's rented, right? So this syntax creates a new variable. It is a binary variable that takes the value of 1 if the original variable is either 1 or 2, and the value of 0 if the original variable is 4, right? And then what I do, I remove the cases with missing age, that's -9. That's going to produce data set like this. Please note that when I create a new variable for age, I don't replace the original data. That's bad practice. Once you replaced your data column, there's no way to get back. You need to start with the original data file. So I create a new variable here. That's kind of a clean version of this. And then what I do, I create a chart, a plot, where I use a smooth curve to show the relationship between age and the home ownership status and the household level. Let me do this. Oops. And that's what we get, right? And it's interesting, and it's good that we use the non-parametric estimation here rather than a kind of a linear relationship. It clearly shows that what we have here is that before age 5, a relatively large proportion of people, before age 25, sorry, a relatively large proportion of people live in households where the house or flat is owned because they live with their parents often, right? And then by the age of 25, they leave their parents' home. Young people often, well, some of them continue living with their parents, but you see that the proportion of home ownership at the age of 25, and then that's something we would expect. People in the age group 60 to 70 are the people where we have the maximum proportion of home ownership. Then it goes down after the age of 75, but see the confidence intervals here are very large because we only have very few people aged over 80 or 90. So I wouldn't put too much emphasis on interpreting this data. Maybe these are the people who move to care homes and so on. All right, let's move on. And I only need 2 minutes now to finish my presentation because I'm seriously over time and I apologize for this. The summary from this example is that when you join the individual and household level data, you need to use the household identifiers, right? And they are wave specific. They cannot be joined directly because it doesn't make sense. If you want the data for the same individuals from household files from different waves, what you need to do, you join these household data via an individual. So you end up with a data set at the individual level rather than household level. And my last example today is to explore the structure of interethnic marriages and cohabitations in the UK. And in terms of data management, that's an interesting example because now what we want to do, before that, we use the data in the individual level or the household level. Now we want the data at the level of pairs of people, of individuals. That's going to be wife and husband or 2 people who live together, right? And in order to create such a data set, we need to know the relationship between different individuals in our data. So how can we do this with the Understanding Society data? We can do this using the data from the ego-alt files that are available for each wave. And these are the files that contain information about relationships for individuals, between individuals within households. So let me open the file, the ego-alt file for wave 10. It's a very long file, as you see, over 100,000 rows. And what it has, the level of observation, the rows here represent pairs of individuals. So the first individual is this one, PIDP. The second one is here, APIDP, right? And then we have a variable called relationship underscore dv. Dv means it derived, right? That shows the type of relationship between these two people. It can be different types: husband, wife, child, parent, grandparent, and so on. Right, so if we look at the distribution in this variable, there are multiple values here. If you check the data dictionary, you'll see that 1 refers to husband or wife, and 2 refers to partner or cohabitees. And that's what we need, both 1 and 2 for this example. So, and note that each couple is represented in this data frame twice, right? So first we have, the first row is going to be, for example, wife is going to be presented as PIDP and husband as APIDP. And the second observation, the second rule for the same couple is going to be husband as PIDP and wife as APIDP. How do you know this? You learn from experience. I spent a couple of hours figuring this out, but this is the inevitable kind of part of the data analysis with understanding society. Right, let's go quickly through the very last part of my syntax. I start with this egoalt file, and I only select the variables I need. These are going to be the, these are going to be the data on identifiers, individual identifiers, the sex of PIDP, and the relationship between PIDP and APIDP. I only keep the spouses or partners in the data, and that's going to be the type of relationship, either 1 or 2. Now, what I want to do is I want to have only 1 row for each couple. So I'm only going to leave the observations where PIDP is a woman, which also filters out same-sex couples, I'm afraid. Actually, unless, and I think there is a separate type of relationship for same-sex couples, but I'm mostly here interested in heterosexual couples. You can also obviously analyze same-sex couples with this data, which can be different tasks. Actually, we do have. No, it's different. Never mind. Okay, so now I have 1 rule for each couple. Now I join with the data on ethnicity, and these data are in a separate file. Where is this data? We already know this. It's in the file with time constant characteristics. That's going to be a variable called ethndv, which is slightly different from what we used before, but I don't have time to explain this. So we are going to use left join to join first. We are going to join the ethnicity variable for women, for PIDP. Now it's, oops, apologies. Right, so it's there. We are going to rename this variable to make clear that it refers to PIDP, to women. Apologies, I'm trying to make it quickly and I make mistakes as a result. Okay, I'll just explain it and I'll run everything together. Then what we are going to do after this, we are going to join the same data with the data on APIDP on man, right? But the difficulty here is going to be that the key variables are going to have different names, right? So APIDP here refers to man, but for in the data files with the time constant information and individuals, that's going to be PIDP. So we can bypass this problem by specifying this in the syntax for left join. So then again, I select only the variables I need. Then after this, I rename the variable so that it is clear for us that it refers to APIDP to man, right? And then I save this data frame as a separate data frame. So let's do this. All right, and then let's look at the data frame we have. That's what we have, right? Here we have the data on women, on man, on the relationship between them, and the ethnicity for women and for men. And now what we may want to do is to look at all combinations, or all the combinations of ethnicities for wives and husbands, or for partners of different sex, right? So that's what we have, a very long file. For example, this is going to show us that for we have one stands for white British, right? So we have about 8,500 couples where both the woman and the man are white British, right? And we may want now to present this data in a different format. So basically as a table where we have ethnicities of wives in rows and ethnicities of husbands, ethnicities of women in rows and ethnicities of men in columns. So we can do this transforming the data from the long into the wide format, right? I'll just run this syntax to show you how it looks like. That's a different representation of the same data set. I'll finish here. Basically, I finished my example. There are a couple of things I wanted to say here at the end, but maybe I can mention them when I answer the questions. I do apologize for running late with my presentation, but let's see what we have in the questions. Okay, let's look at the questions. Question for Q&A. Would you be able to use the guidelines from today to work with the BHPS? Yeah, I've never worked with BHPS, but there shouldn't be major differences. I would expect the identifiers would be different. So PIDP is not there. It should be different, something different. But basically all the data routines are similar because the structure of the data set is the same. Okay. Would it be better to use both X-wave dot and wave 10 time invariant data? Or is the time invariant data present in wave 10 and also present in the X-wave dot file? The X-wave dot file contains time constant information for all the individuals who ever participated in the Understanding Society, right? So all the time constant information is in X-wave dot, right? There is no separate file with time constant information for wave 10, because if it's only wave 10, how do you know it's time constant? Yeah, so all the time constant information is in the time constant file, which is X-wave dot. When do you use PID? I saw syntax file using both PIDP and PID for merging. Is that when you merge with other files within the same wave? I don't know the answer to this question. I always use PIDP, and I believe when I link information about individuals, and I believe it's okay. PID is probably a wave-specific individual identifier, although I'm not sure what's PID. Let's take a look. Basically, I don't know the answer to this question, but I'm trying to figure it out now. It's for BHPS. Okay, we get the answer now. That's why I don't know about it, because I never worked with the BHPS. So PID is for BHPS. So I guess whenever you link with the BHPS data, you need to use PID. Okay, right. Would it be possible to get even the geographic dimension of data, for example, Southwest England, Wales, and so on? Yes, there is a variable for this at this level. If you want a final level, for example, Southwest England is rather broad. If you want to know to see the observations from Exeter, or even a particular postcode, you need to apply for the data with a special license. There are 3 levels of security for the Understanding Society data. So there's a public release that you can just go on the UK Data Service website and basically download with minimum checks. There is also special license data where I believe they have the detailed geographical information, and you can also access it from your office, but there are some separate requirements. You need to pass the training, and also there need to be some technological infrastructure in play, the VPN. So it is possible to access it, but you need to apply and do certain things. And there's also secure access data that has even stricter requirements for access. You need to do it in a secure data lab. For example, that would be a requirement for genetic information. But at the level of Southwest and Wales, it's in the public release. I see you only show the data in wide format now, but once you run more complex longitudinal analysis, that is, what is the preferred data format? I guess it could be long. It can be long indeed. So for panel regressions, if you want something like fixed effects or random effects, you need to convert your data into the long format. So you need to use pivot longer. I haven't shown this today, but yes, that's what you need to do. And I believe these are all the questions in the chat.